Dissecting a line of obfuscated Python. I was reading another question on Stack Overflow, Zen of Python, and I came across this line in Jamie Soriano's answer. Entering the above in a Python shell prints. And so of course I was compelled to spend my entire morning trying to understand the above list comprehension thing. I hesitate to flatly declare it obfuscated, but only because I've been programming for just a month and a half and so am unsure as to whether or not such constructions are commonplace in Python. This .s contains an encoded version of the above printout. And this .d contains a dictionary with the cipher that decodes this .s. As far as I can tell, the flow of execution in Jaime's code is like this. 1. The loop C for C in this .s assigns a value to C. 2. If the statement C in this .d evaluates to true, the AND statement executes whatever happens to be to its immediate right, in this case this .d, C. 3. If the statement C in this .d evaluates to false, which never happens in Jaime's code, the OR statement executes whatever happens to be to its immediate right, in this case the loop C for C in this .s. Am I correct about that flow? Even if I am correct about the order of execution, this still leaves me with a ton of questions. Why is 1. the first thing to execute, even though the code for it comes last on the line after several conditional statements? In other words, why does the for loop begin to execute and assign value, but then only actually return a value at a later point in the code execution, if at all? Also, for bonus points, what's with the weird line in the Zen file about the Dutch? Edit, though it shames me to say it now, until 3 seconds ago I assumed Guido van Rossum was Italian. After reading his Wikipedia article, I at least grasp, if not fully understand, why that line is in there.
The operators in the list comprehension line associate like this. Removing the list comprehension. Removing the AND or Boolean trickery, which is used to emulate a if-else statement.
You are correct about the flow. The loop is of kind dosomething, C, for C in this .s, it's a list comprehension, and should be read as dosomething for all C in this .s. The Dutch part is about Guido van Rossum, creator of Python is Dutch.
Your analysis is close. It is a list comprehension. BTW, the same output would result if the outer square brackets were eliminated, which would be called a generator comprehension. There is some documentation here. The basic form of a list comprehension is: they are evaluated in this order. Enumerable is evaluated. Each value in turn is assigned to var. Condition is checked. Expression is evaluated. The result is the list of expression values for each element in the enumerable for which the condition was true. This example doesn't use a condition, so what is left, after adding some parentheses, is this .s is the enumerable. C is the iterating variable. C in this .d and this .d, C, or C is the expression. C in this .d and this .d, C, or C uses the short-circuiting nature of Python's logical operators to achieve the same thing as this .d, C, if C and this .dlc. All in all, I would not call this obfuscated at all. Once you understand the power of list comprehensions, it will look quite natural.
Generally, list comprehensions are of the following form. When I write down a list comprehension, I often start by writing. Because many years of procedural programming has inculcated the for loop aspect into my mind as the part that comes first. And, as you've rightly noted, the for loop is the part that seems to execute first. For each pass through the loop, the expression is evaluated. A minor point, expressions are evaluated, statements are executed. So in this case, we have this.s is a string. In Python, strings are iterators. When you write, the loop iterates over the characters in the string. So C takes on each of the characters in this.s in order. Now the expression is. This is what's known as a ternary operation. That link explains the logic, but the basic idea is. The condition C in this.d is thus simply to check that the dict this.d has a key with value C. If it does, return this.d, C, and if it doesn't, return C itself. Another way to write it would be. The second argument to the get method is the default value returned when the first argument is not in the dict. PS the ternary form is error-prone. Consider what happens if condition is true, but value 1 is none. Since condition is true, you might expect the ternary form to evaluate to value 1, that is, none. But since none has Boolean value false, the ternary form evaluates to value 2 instead. Thus, if you are not careful and aware of this pitfall, the ternary form can introduce errors. For modern versions of Python, a better way to write this would be. It is not susceptible to the pitfall mentioned above. If condition is true, the expression always evaluates to value 1. But in the particular case above, I prefer this.d.get, C.
.join, C in this.d and this.d, C, or C for C in this.s, is certainly obfuscated. Here's a Zen version. This.s.decode, rot 13.
If you want to support the channel, please consider liking and subscribing.